Today we have three different sections. We have introduction to Spark SQL, where we have hands-on on coding. There are few talks from Hawaii on Spark and Hadoop ecosystem. There is also one session where we are going to talk more about community part. Right, so this is going to be the three different sections in the Spark meetup, and of course there is a lunch. So after the meetup, don't go. Right, have a lunch and be here so that we can talk more. Right, so that's going to be the idea. Let us start with the first session. Now, to give you the better idea, myself, right? So my name is Madhukara Phatak. I run a company called Data Mantra. I am a consultant on Spark and Hadoop. I am working in Hadoop from last 5 years. And if you want to connect on the internet, so that's the website. So LinkedIn, Twitter, everywhere, right? And again, we'll put all the slides and code everything in the online. Right, let us start. So how many of you done anything with the Spark before? Like just experimenting? Oh, great, so most of you. How many of you done anything with the Hadoop? Like Hadoop, Hive, Pig? Oh, most of you know already the big data world. Right, so what we are going to talk today is, last few meetups we have talked about Spark API, RDDs, Spark streaming. Today we are going to focus on Spark SQL, or more broadly we are going to focus on structured data analysis. Right, so that's going to be our theme. And the agenda is, this is the agenda. We are going to talk about what is the structured data means, right, why we are talking about that. And also in my slides, there is no slide saying any questions. So if you have questions, you can ask in between, right? It's encouraged to ask the questions in between, right? And I'm hoping everyone is able to see the screen from everywhere, right? Okay, let's start. Now, if you are new to big data, the first thing you maybe have learned that there are 3 V's in big data, right? So this is a both marketing and technical jargon, right? They say, okay, if you are know big data, these are the 3 V's you have to know. Now, why these 3 V's are important is, when we hear about big data, normally what we think about volume, right? We say, oh, big data means lot of data. But that is not purely true, because there are multiple facets you have to know about big data. One of the things is, we say about volume, right? We say terabytes, petabytes means big data. Now, the second line what it says is, when you have a specific problem, what kind of frameworks are getting pushed? Or we can say, what kind of frameworks people are putting effort to make it faster or better. When you talk about volume, all the batch processing system like Spark Batch API, Hadoop MapReduce, those are the frameworks pushing the art of things, right? They are towards this solving the problem of volume. For example, when the Hadoop MapReduce came along, the idea is that it can process terabytes or petabytes of data. Right? Now with the same idea, volume is okay, but nowadays we are living in the time of velocity, which means terabytes and petabytes are great, but we are getting terabytes and petabytes in few seconds. If you are a company like Twitter or anything real time, you want to get the data like terabytes and petabytes, but you want to do the processing in few seconds. Right, so which means now we have a new problem called velocity, where we say, okay, we have a lot of data, but the batch processing system like MapReduce cannot solve the problem, because it takes half an hour and I just have few minutes. So that's why the systems like Spark Streaming, Storm, they are getting pushed. Right? People are building new frameworks where what they are doing is that they are solving the velocity problem of the big data. So what we are trying to say here is that there are different problems in the big data, and for every problem there are specific frameworks are built over a time. And if you've seen the videos, or if you've been earlier, we already talked about volume and velocity. Right? So we already talked about batch API part, we already talked about the streaming part. Now today we are going to focus on the variety part. Now what is the variety? Variety means 2 things. The first thing is that we are collecting different kind of data. Right? We are no more living in a dream world of RDBMS. Right? There is only one storage earlier, RDBMS, and everyone is happy. Not really, but you should be happy with that. Right? So we had a nice schema and everyone is happy. But nowadays we are living in a world where there is structured data, unstructured data, and semi-structured data. Right? You get all kind of data. And second thing is that you just don't write SQL queries anymore. Right? You have to do different kind of processing. You want to do SQL processing, you want to do graph processing, you want to do machine learning, like you want to do different kind of processing on different kind of data. Which means big data, not only volume and velocity is important, when we want to do processing, there is a variety in it. One is the source of the data is variety, right? There is a different kind of data. And there's also different kind of processing we want to do. We want to do graph, different kind of things. And each of these processing needs different kind of frameworks, because batch processing like MapReduce may not be great for graph processing, right? One of them we are going to talk about today is SQL, right? So how to do a structured analysis where we want to write SQL queries. Of course, in the coming sessions, we're going to talk about graph processing or machine learning, all those kind of things. Today, we are going to focus on one of the variety where we have a structured data and we want to do SQL processing on top. Are you able to follow?
Yes, sir.
Right, great. Let's move on. Now, you can ask why we care about structured data. Because when there is a big data hype, the first thing it says, it's all about unstructured data, right? Right. What is big data? It is a processing engine which can handle unstructured data. Not really. So how many of you are really using Hadoop or Spark in day-to-day work here? Okay. And how many of you most of the time work with structured data? Right? Most of the time. Of course, there are a lot of use cases like text analysis, machine learning, and those kind of places where we say, okay, so purely unstructured data. But most of the work I do and most of the other people, if you talk to them, they say 80% of the time I still work with the structured data. That's the one thing. The second thing is that even if I have unstructured data, I don't work with unstructured data. What I do, I run a huge ETL process which takes the unstructured data, takes the schema out of it, or you apply some schema, then you work with it. Right? So there is a two process. Maybe sometimes I start with the structured data, I do processing, or I start with unstructured data, apply some schema for specific to that processing, then I work with it. Right? So these are the two scenarios. Now, for example, where the data structure, like structured data comes, here structured means loosely coupled structure, not exactly like RDBMS. If you take an example, JSON data coming from APIs. For example, if you are connecting to Twitter, Facebook, or even internal APIs, most of the APIs are exposing JSON data. Right? You are collecting JSON data and crunching that. Maybe a lot of data is already in RDBMS, your transactional data or whatever it is. Right? That is a very structured data. NoSQL DB inputs. How many of you use the NoSQL databases? HBase, MongoDB, Cassandra, those kind of things. So they are structured in a way that loosely coupled structure. So there was a person saying that, okay, MongoDB is purely non-schema system, right? But what we do is that we write the schema in the program. So it's just the schema is moved from database to the program, but there is a still schema, right? So even if we say NoSQL, we are still talking about loosely coupled structure here. Right? What I'm trying to say here is that even though we think most of the time big data is unstructured, most of the time we are still working with the structured sources. Even if you don't have structured sources, what we do, we run a lot of ETL in order to get a structure out of unstructured data. Now you can say, then how is different than RDBMS world? If you have done data warehousing before big data time, you say that's what we are doing, right? We had a schema, we are doing SQL processing on top of it. Is it exactly same? Not really. So the difference is, in the RDBMS world, what we do is that when we inject the data, we define the schema, right? We say, okay, this is the schema, this is how we are going to inject the data. But in the big data world, what we do is that we collect the data as it is, put in the raw form, and only for processing, we define the schema. So there is a one sentence called data first, schema next, right? We collect the data as in raw form, and when we want to process it, we put a structure on top. So it's not exactly like RDBMS, because in the typical data warehousing, once you put that schema, all the data, other data will be lost. But in the big data system, you have all the raw data, but only for processing purpose, you define some schema. This is exactly like what we do in Hive. How many of you use Hive, right? So we put a CSV and we say, okay, this is the schema order. Right, next. Now, what is the thing about structured data in MR world? Why we are talking about Spark SQL when there are already Hive and great things are built on Hadoop, right? Impala is there, Hive is there. Why we are talking about something new? Now we say, how many of you done MapReduce in Java? Somewhat of time, okay, some of you here. So in MapReduce, both structured and unstructured data is treated as a text file. Here I'm just talking about text file. It can be true with the binary file. There is no real differentiation. The MapReduce do not care, is it a CSV file or is it a JSON file, nothing. It says, okay, it's a text file, I'm going to divide like 64 MB. Right, that's what it does. So there is no real differentiation between, okay, this is structured data or unstructured data. It has some issues, we'll see what is the issue with that. And even the higher level frameworks like Pig or Hive, if you already worked with them, they don't do any schema discovery. What they do is that they match the schema provided by the user to the file. For example, if you work with a Hive, what you have to do, you have to say create table. This is my schema. Then it says, okay, let's hope that it's going to match your data. Right, so hope. You never know. Same with the pig. When I say load this from pig, then we have to say as this is the schema. If you don't say the schema, then you will get all the things like byte array or something. Right, so even the pig or Hive, what they are allowing you to do is that, okay, I will tell you how to read the record, but I don't care what is the schema really. You have to tell me what exactly the schema. Which means even in the Hive and pig, there is no real way of saying this is structured data, you discover the schema or something. It's like I give the schema, I give the data, let's hope both match kind of world, right? Because Hive and pig are written on MapReduce, and MapReduce do not have a way to say what is the differentiation between structured or unstructured data. Now, what we do is that before we start doing the structured analysis, let us see what we do today. Let us say if I have a CSV file with me, if I'm writing a MapReduce, I'm giving in the Spark example, even it applies for a Hadoop also, what we do today and what are the issues with that. And I'm hoping that most of you guys downloaded the code and those kind of things. If you're not set up, don't worry, everything is in the GitHub with all the instructions. You can run afterwards also. Make sense? Okay, let us see the code. And if you guys already have set up, you can run with me. Right? I think CSV and RDD. Yeah. Right. So what I'm trying to show you here is that I have a CSV file sitting in let us say HDFS or some file system. The first line is a header. That's what we get in any CSV. Then I have a comma separated values. Right. This is very simple. And I'm hoping, how many of you seen Spark code before? Okay, how many of you seen Scala code before? Okay, so you can read the code, right? So even if you're not able to understand everything, if you are able to read the code, that's fine. And most of the code is like 4 lines or 5 lines, right? So that is not much. What I'm doing is that I'm creating a context here. Then I'm loading the file. Once I load the file, it's an RDD. Then what I do is that I take out the first line because in RDD there is no concept of structured data analysis. It's just a text file. You do not know what is a CSV is. So what I say, okay, no, don't look at first line because first line has actual data fields. Then what I do, I filter them so that I only get the lines which don't have the first line kind of a thing. Then what I do is that for every line, I create a custom object called sales. So this object is a custom custom class or domain class, right, which contains these parameters. Let us open that sales file. Let me show you, right? Okay, sales is a case class which has all those fields. So what I do, I start with a very raw text input, then I'll convert into a domain class. How many of you do this? Like this is what we do it in Hadoop also. We create a writables. In Spark, we don't need to have a writables. You just create some domain class. What we do is that we start with the raw input, then we convert into a domain class so that we can work with it, rather than working with the raw text. Are you able to follow? And this is same in any MapReduce program, and this is actually same in Pig also, right? We load the data and we say these are the fields. Make sense? Okay. Now we'll not run this because I think everyone knows what should be the output. The question is, what is wrong with it? If everyone is happy with it, then we don't need to talk about Spark SQL, right? Because this is fine, everything is great, right? We can do RDD processing on structured data. Now what is the problem? Let's go to the slides. Right. The first problem is that there is no uniform way of loading structured data. What we do is that, I think if you have seen my earlier talks or if you know how the Spark works, it internally uses input format. I think you know what the input format is, right? So internally what it does is it's using a Hadoop input format and says, take this text file, give me all the splits, right? So what we are doing is that structured or unstructured, we are just piggybacking on the input format. We are just saying, okay, take this data, give me as a text file, I will do all the kind of schema extraction in the application itself. Right, so that's what we are doing here. Even in Hadoop or Spark, it's exactly the same. Now, that's not great, right? And also, where is the schema in CSV? The schema is in the file. The first line actually has the field names. And if you look at the data, you know what is the type of things, right? How many kind of things CSV can have? It can have strings, it can have integer, it can have double, that's all. Now, but what you have to do in the application as of now is that you have to tell the schema. right? So there is no way of auto discovering the schema, which is very, very bad, because let us say I am connecting to RDBMS through some input format. You should be able to say, okay, I know RDBMS, let me see what is the schema. But what I do in this, okay, I get the data from RDBMS, I tell the schema again. Now what is the problem if you don't have a schema discovery? What is the problem? Any idea? If you are specifying the schema in two places, one in the data source and one in the application, what is the problem?
Whenever there is a change in the source.
Yeah, whenever there is a change in one place, having a consistency is a big problem. Right? You updated the schema, let us in RDBMS, but you forgot to update in your MapReduce code. Then what happens? Whatever the data you're importing from RDBMS has some other schema, then suddenly everything is stopped. And there's no way of saying that, okay, everything is consistent. Now, then what we do, we have a process inside a company saying that, okay, whenever there's update, we'll make sure that everything is updated. That is the one way. The second thing is that, let us say, even the simplest things, what we are doing in the earlier program. Let us say my fields are get switched. Let us say my first field used to be ID, now the ID becomes the second field. Now everywhere where we used to do the passing, we have to say, oh no, don't say 0, let's say 1. Right? Even if I have a same schema, but if my number of the fields are getting switched, then I can have the same problem. Right? I think this is the same problem what we had in the Java, and how we solved this through Hibernate or any ORM systems, right, which has this mapping somewhere. But what happens is that when you don't have a way to discover the schema, you are specifying in multiple places. And when you have a data flow system in your company, let us say you are using Hadoop, you have MapReduce, you have Hive and Pig. Now, how many places you are putting schema? 3 places. Right? You have some schema in MapReduce, you have some schema sitting in Hive, you have some schema sitting in Pig. Now, let us say you change in one place. You have to make sure that it is updated everywhere. Right? So, what's happening these days is that we are not using any more one framework in big data. We are using multiple frameworks, and all these frameworks has their own way of saying this is how you have to specify the schema. Which means what we really need is that not to way to specify the schema, we want to have a way to say discover the schema. Right? Then it's great, because whatever is changed, the source knows the actual truth, and it will tell, okay, this is the new schema. Discover it. Of course, we can do versioning. How many of you use Avro or Drift and those kind of things? So they are kind of ways we can say version, okay, this is the version, old version of the schema. You can have upgradation of schema, those kind of things. All those kind of things are there out there. Of course, adding a new field or changing a field sequencing is not so easy. What you have to do is that you have to change the programming in a lot of places, and when you have multiple systems talking to each other, you have to change in a lot of places. Now we can say, Pig has JSON input format, right? Does it do schema discovery? Not really. What it does is, it does simple thing. It says, from this record to this record is a JSON record. I will give you the JSON record. But after that is your problem. Right, so all the input formats that is in Pig or MapReduce, they are not towards schema discovery. What they do is that they do record separation. For example, if you've done XML parsing in MapReduce, what it does, it says from this tag to this tag is a one record. I will give you the record, whatever you want to do with XML is up to you. Right, so even if you have a JSON input format or XML input format in MapReduce, they don't do schema discovery. What they do is that they do the record separation. That is great, that's what we want for some places, but that is not enough. That's what I'm trying to put here. And also, another problem we have is, it's not about just schema discovery. Once we have a schema, how we represent it in the program. Right, for example, in MapReduce, what we have? Key value pairs. Then what happens is that if you read from a DB, then you get DB input format and you get maybe DB row. If you are reading from JSON, you get maybe JSON row. Right, which means for each structured data, what you get is its own key and value pair. Which means there is no one way of saying this is the structured data. No, it's not like RDBMS. RDBMS says I only know two things, rows and columns. I don't care which table it is, there's only rows and columns. But in MapReduce world, we have this idea of key value pair data types, and for each structured data, we have a different key value pairs. Which means I have to convert between, let us say, I have a JSON data, I have to get a JSON row, convert into something else. Now, that is not even great in RDD, because if you see in RDD has the type T. Right? What is that type T says? What is the record type? Now, T says for JSON, if you load, you get JSON RDD. If you load, let us say CSV, you get CSV RDD. Which means they are not saying they are uniform across all structured data, they are just specialized RDDs. So which means even the RDD abstraction is not good enough to represent the schema what is coming out of the structured data. So it's a multiple level problem. First, we don't have a schema discovery in input format. Even if I am able to discover the data, now if I have two programs talking to each other about structured data, there is no high level abstraction saying that this is the way to represent all the structured data in the program. Right? We don't have that kind of things. And finally, of course, if you are using a batch processing system of the Spark, there is no way to query structured data nicely. Right? So even if you get structured data in CSV, what you have to write? MapReduce. And if you have structured data, there are better ways to query that data. Are you able to follow what I'm trying to say? Right? So there are three different level problems. One, we want to have a schema discovery. Second, once I've discovered the schema, I want to represent it in such a way that irrespective of which source it comes from, I want to have a single representation. The third thing is that once I have that high level abstraction, I want to query it. Are you able to follow? Any questions still here? Okay. Now, to solve the specific problem of the structured data, we have a Spark SQL library. Now, I know people who are coming to Spark SQL session, they have this, okay, this may be Hive on top of Spark. Right? That's what we normally think. So we had Hive where we are able to write SQL queries on MapReduce. Spark SQL may be writing SQL queries on top of Spark. Not really. Spark SQL is a collection of APIs which solves the structured data analysis end to end. It's not just writing SQL queries. And in my session actually, there is only one slide on real SQL. I'm not really going to focus on SQL because I think most of you have worked on the Hive before and the SQL language is exactly same. So you don't need to learn something new. So I'm not going to focus on actual SQL, but the library has so many other APIs. The first thing is that there is an API called Data Source API, which is a universal API for loading and saving structured data, which means in Spark, other than input format, now we have an API which says, I know how to load a structured data. No more we are saying, okay, all are same. And we have a dedicated API called Data Source API. Then we have a DataFrame API. Once I load the data, there is a universal way of saying this is the way to represent the structured data inside a program called as a DataFrame. And of course, there is a SQL interpreter and optimizer. We are going to talk about it. Once you have a structured data loaded, you can query through SQL. And there is a SQL service. How many of you used JDBC on Hive? Right? You have a thrift server. Same also there. And I am going to focus on actually the first two aspects more on this session, because they are new to you, I think, even if you are coming from Hadoop world. Right? You've not seen these kind of things before, but I think you already seen Hive or those kind of things, which means you know how to write SQL in big data. Okay, till now, I think there is any questions? Okay. Now, before I go with the Spark SQL, of course I have to do a comparison with the Hive. And how many of you using Impala? Here, any? Okay, so if you have any specific question about Impala, you can ask. I will not put the Impala here because I think not many people know about Impala, but I can answer even that. First difference between Spark SQL and Hive is, Spark SQL is a library and Hive is a framework. And I think if you are used a framework versus library any point of time, you know how big difference it is. The idea of Spark is it encourages to have more libraries rather than frameworks. In terms of Hadoop, they encourage more frameworks than libraries. Now, what is the difference between a framework and library? Library means you can integrate with any other library, it's just a call to that library. Framework means you have your own installation, your own way of representing things, all those kind of things. Spark SQL, there is no new installation, it's just part of your normal Spark program. It's a library. Hive, it's a framework, it has its own meta store, etc., lot of things. Now in Spark SQL, the meta store is optional, right? If you done Hive, you have to create a meta store, maybe in the Derby or MySQL, those kind of things. In Spark SQL, you don't need a meta store. How we do the things, we'll see. But it is very similar to pig. And in the pig, the schema is on the fly. After the pig is done, that schema do not need to be leaving. Of course, you can use hash catalog and those kind of things, but that is not mandatory. In Hive, meta store is mandatory. Right? You need to have a meta store, otherwise you cannot run Hive. Now, In Spark SQL, it has automatic schema inference. You don't need to say create table. It can understand the schema. Of course, you can give a schema, but most of the time it's a schema inferred. In Hive, of course, you have to create a table, right? You say create table this and comma separated or whatever it is. There is an API. Now, this is the big difference. In Hive, there is only one way of querying the data, that is SQL. But in Spark SQL, there are two APIs actually. One is your normal SQL one, and there is something called DataFrame DSL, domain-specific language. Anyone of you worked on R or Python Panda, some point of time? Okay, so if you're coming from there, you know about DataFrames. We'll talk a little bit about it anyway. It supports both Spark SQL and SQL. One nice thing about Spark SQL is that it supports all your Hive queries. Right? If you already done Hive before, there is a direct support for that. You can say, I want Hive language. Whole language is supported. In Hive, of course, they only support their own language. They don't support Spark SQL. Now, another nice thing about Spark SQL is that they don't have their own JDBC server. They just use the Hive JDBC server. So if you have worked with the Hive JDBC service, which is running normally on 10,000 port, Spark just uses it, right? Now, what is the big difference you see here is that Spark SQL has this idea of approaching as a library, which means they want to integrate with all other Spark ecosystem rather than saying we do things in our own way. Are you able to follow what I'm trying to say? Hive is just another piece which saying we do SQL queries on MapReduce, right? So that is a big difference. Now, let us say before we get into the data source API, so what we're going to do in the next part of the session is that we looked at 4 APIs. We are going to talk about one of them at a time, right? Now let us say, what is the problem with the input format? I think I kind of told you this a little bit earlier, but just to focus on it, the first thing is that input format needs key value pairs. Why? Because it was designed for MapReduce, and MapReduce only works with key value pairs. But when you came to Spark, that idea of key value pair went away because we can work with the non-key value pairs in the Spark. And when you come to structured data, it do not make any sense to have always the key value pairs. Which means input format by nature was not designed for this. That's why people were hacking around it, making sure that everything is key value pair kind of stuff. We don't need that. Of course, there is no schema discovery inbuilt. You can hack around it by sending some information, but input format I think has only 2 APIs, get splits and get record reader. Right? It only knows about those 2 things. There is no direct support for smart sources. Now, this is very important these days. Let us say you are doing a filtering in MapReduce, and the data is coming from RDBMS. Now, what we do in MapReduce is that we read a whole row from the RDBMS, and in the MapReduce side we get a column. Right? Let us say I only want 10 columns. What I do, I read whole row from the RDBMS, then I only get those 10 columns for processing. The problem is that is slow. We are just reading, let us say I have 100 columns in the RDBMS. I'm just reading 90 columns without any real integration. Right? We're saying, okay, get me all the columns, I will select in the processing. But what is the better way? Better way is that I should be able to tell to RDBMS that, see, for this processing, I only need 10 columns. Only send me the 10 columns. Are you able to follow what I'm trying to say? What is a smart source means? The source itself has a processing power where I can say, I only give you the data which you require, rather than me taking the whole data and filtering in the processing side. Because if you apply that in the scale, it really matters. And there are more and more smart sources. RDBMS is a smart source. Your NoSQL DBs, they are really smart about selecting columns. And we are going to talk about one file format which is smart on top of even the disk. Which means we need a way to tell to the source that this is the data I want. Just give me that. In input format, there is no way of telling that. Input format, there are ways to say, set this configuration and those kind of things. But there are no straightforward saying that I only need these columns. You make the decision that how best you can read from the file or the RDBMS or any DBs. Which means what we are seeing these days is not only our processing engines are smart, we have the sources also which are really smart. We want to have a richer integration rather than saying just treating the source as a dumb data source where we say pull all the data and then we do the queries. All are able to follow what I'm trying to say? Okay, right. So that's why we don't need a thing. Now, what exactly is data source API? Data source API is part of Spark SQL package. You have lot of data sources. For example, I think everyone knows Hive. We have Spark SQL has direct integration with the Hive. You have Avro, CSV, Parquet we are going to talk, JDBC, HBase, others. These are structured data sources. you have so many processing engines who want to access structured data. For example, all your BI tools which want to connect to a JDBC server, and all your Spark applications which they want to get the structured data, which means Spark SQL is an interface between the structured data source and structured data processing. Are you able to follow what I'm trying to say? So that's where the data source API sits. So it's kind of abstraction between structured data sources and structured data analysis. In the big data, it used to be input format, don't care what is the data source, don't care what is the processing. That's the only way. So, but we are doing better, right? Okay, let's move on. Now, what is data source API? It's an universal API for loading any kind of structured data in Spark. Okay, so any kind of structured data. It's not only for loading, it has support for saving also. You can save it on RDBMS, NoSQL. You can save the structured data on top of the disk. Built-in support for Hive, Avro, JSON, JDBC, Parquet. These are built into the Spark SQL. You don't have to do anything. Of course, you are not limited by this. There are a lot of third-party integration using a new initiative called Spark Packages. How many of you heard Spark Packages? If you are not, I encourage you to go to the website Spark Packages. It is a community website where people can submit their libraries which are built on top of Spark. You can think like a Maven Central, but this is for discovery. Of course, these libraries are there in Maven and other places. So you can go to this website, you can search, okay, I want to integrate with MongoDB. I don't want to write my own library. Let us see if someone is done or not, that kind of thing. Right, so from this third-party integration, there are support for this. For example, there is a support for CSV data. We are going to see today from Databricks. There is a support from MongoDB from the MongoDB team itself. There is a Cassandra support also from DataX. They are working on it. It's not 100% complete. Here, what I mean support is they support data source APIs, and we will see how nice to work with them. So the idea here is that there is a lot of built-in support from the Spark, but now community is embracing these APIs so that there is a single way of loading structured data from any source you want. Are you able to follow? So that's the kind of a thing we are trying to get. And if you want to write your own data source API, it's possible. It's just an API in the Spark. You can write access to your own data source which is sitting inside your company. Maybe you have your own custom data source. And we are planning to have one session some point of time saying how to write our own data source APIs. That's a kind of advanced stuff. But you can plug into whatever the data source you have in your own company. That's also possible. But most of the time, if you are working with the outside sources, you have built-in support, or most of the time you have a library to work with. Yeah.
Suppose we don't use Spark SQL mid-layer.
Yeah.
We directly have other packages, mlib, and
Correct.
talk to data source.
Yeah.
What difference it makes?
Yeah, so that's a good question. The question is that if you don't use the Spark SQL interpreter, if I'm using MLA, that is a good question. The answer is that we are going to talk about DataFrames. Now, DataFrames is going to be supported in all the packages. Now, MLib is already using data source APIs. Right, so we are going to a little bit talk about that, which means you don't need to write SQL to get use of this API, because SQL is one part of Spark SQL library, but other APIs you can use independently also. We'll see that. Any other questions? Are you able to follow, or is too much to train? Okay. Now, how to access data source APIs? From here, we'll run some example just to get a feeling that, okay, what is the data source API? For accessing data source API, I think everyone knows Spark Context. That's how we create an RDD. Similar to Spark Context, we have something called SQL Context. So SQL Context is a way to access any Spark SQL libraries or any APIs, right? And SQL Context is nothing to do with like how Spark Context creates our JVMs and those kind of things. It's just a wrapper around Spark Context. It's just a library call, not really creating any processing power. SQL Context Load API is a way to load any data source. Okay, so there is an API called load. We'll see what are the properties it takes. We can say, okay, load the data, then you get some representation. Now what we do is that we are going to have an example for how to load the CSV. We've already seen how to load the CSV in RDD. Now let us see how we load the CSV in data source API. We are going to see JSON data also. What I have is, in my example, I have two files with the same schema but with a different structure. One is a CSV file, one is a JSON file, but both have the same data, but just the representation is different. Now what we want is that when we say, can we mix and match these sources? Let us say I take some data from CSV, I take the data from JSON which has the same schema, can I mix them? That kind of a thing. Just to give you like idea that why it is called as universal API, right? Let us see the example. And what is the time? Okay, I'm going faster than I thought, I think. Okay. Let us go to the data source, right? CSV data source. Okay, I will go a little bit slow here, just to, and Alt 1. Just, yeah. Now, what we do is any program, of course, we create a Spark context. That's the normal way. But after that, can you see here? We are creating a SQL context. So because if you want to access any Spark SQL APIs, you need to have access to the SQL context. Make sense? Now, how to load our data? We say SQL context.load. Then, what is the source we are reading from? See, if you see the package com databricks.spark.csv, this is meaning that Databricks has put out a library to have a CSV implemented for data source. So this is similar to what we say in input format, right? We say this is the class. We give the full package. Here we are saying in this package you get the implementation for that data source API. Then the second parameter takes is it takes actually options. So option is a map which takes what are the options for data source. Here we take two options. We say which path this file is coming from, the CSV file. And we also say header equal to true. What I mean by here, this CSV has header, which means from that header you can discover the schema. Are you able to follow? If you have any question, because this is the very basic part of the data source API, and if you see, we are no more writing input format or those kind of things. We are saying load the data. This is the source, right? This is where we want to get the implementation of data source. These are the options for that data source. What are the options? This is the path. Because sometimes I may not have a header, then I can say header equal to false. Sometimes I may have a header, then I can say header equal to. Make sense? Now, once you say load, there it will be discovering schema for you. Okay, so it will be auto discover. Once I have that, then I can say whatever it returns. We'll talk about what it returns exactly. We can say df.schema. That will give you the interpreted schema. Are you able to follow what I'm trying to say? You can say df.schema. I just saying because schema has more information. I say df.schema field names to list. I want to say what are the fields are in the schema. But if you see the amount of line of code we have to write for a structured data is very less in the data source API. The reason is that auto discovery of the schema. Because I know in the CSV file the schema is already existing. I don't want to write a new schema for that. So what I say to the data source, you discover the schema and you give it to me. Once I discover the schema, I can look at it and say, what is the schema you have discovered? Are you able to follow? And is it much better than what we wrote earlier in the CSV? Right, earlier we say, oh, first line you don't touch, I will do the parsing, I represent in my own sales thing. We all removed everything. And we say, take the data, this is the source, get me the schema. Once I get you the schema, I will do the interpretation. Make sense? Okay, let us run this. I will show you the example data also. Let me show you the example data. There is a sales.csv. Just go up. Is that the thing? Okay, we don't have a field names. Just go up. Okay, just maybe out of full screen. Okay, I just wanted to show you there are actually field names. Right. So we have field names, transaction ID, customer ID, item ID and amount paid. From there, it will choose those field names. Right. I don't have to say I create a field names again. And this is my normal data, whatever the CSV is. Now what I'll do is that, let us go to the CSV data source.
If header is missing then?
Header is missing, it will generate its own field names, C0, C1, C2. That's the way, right? Okay, let's run this example. I think we have to show you what are the parameter it takes. I'll just stop it. Just go. Let us say, yeah. No. Yeah, edit configurations. Right. So what the parameter it takes is, okay, you have to say the first one is local because this is a what parameter master of the Spark context. Yeah, we'll just give local. and then we give the file path. Here I'm reading from local file system, but you can read from HDFS and those kind of things. Whatever file systems you have in Hadoop, you can talk to them. Did you get the things? Okay, now let us run. Okay, local source, yeah. Just say apply and say okay. Run. Now, I think when we say text file in Spark, I think everyone knows it's a lazy operation. Everyone agrees? Right? Nothing happens, the line executes, nothing happens. But when we say load in SQL context, it's not a lazy operation because it has to do some processing in order to discover the schema. Are you able to follow what I'm trying to say? In the normal Spark, when I say text file in input format, it's a lazy operation, nothing happens. It is not even going to look at the file. But in SQL context, when I say SQL context load, it's not a lazy operation because with being lazy, you cannot discover schema. Right? It does some processing to say this is the schema discovered. Are you all able to follow what I'm trying to say? Now, yeah, just make it big so that we can come down to it. Make it big.
Madhukara, one more question.
Yeah.
Since this is discovering the schema, in one column I have multiple type of elements, like one is numeric, one is text.
Okay.
And we are not specifying the schema. How it intelligently interpret?
Great question. So the question here is that now we know the field names. Now what about field types, right? Now in Spark CSV implementation as of now, all the schema is string, but that is specific to their implementation. They have not yet done the data type checking. But in the JSON, they do have data type. But what they do is that, let us say the question was, what if I have string and a number in the same column? What is the data type? What they do is that they take the parent data types. So the implementation is that if you have integer and the string, what is the parent? String. So you find a common parent in terms of Scala implementation. If you have two data types which are not matching with the data types, they go to the parent data type. Are you able to follow what I'm trying to say? If in terms of string and int, string is a better representation. That's how they do.
So parent is always a string.
Most of the time. But if you have an array, let us say, you have an array and integer, parent may be like any or something, object or something. So then it changes. So most of the data source, what they do is that when there is a mismatching types, they just take the common parent, whichever the common parent is. And most of the time, string is the better thing. But we have a structured data like JSON, where we may have array or object. Then there are some other implementations.
But then there is a hierarchy is defined. Which one is parent? Behind.
Yes, that is specific to data source. So they define, because maybe HBase has different concept, like what does the hierarchy mean. So that is specific to the data source. All are able to follow what we are trying to do here. So what we've seen is that, can we scroll, make it up somehow? Okay, I'm hoping that people are able to see the field names. So what happened is that I told to the data source that the field names are anyway are in the file. Don't make me to give. And it says, great, let me discover it for you. Are you able to follow what I'm trying to say? And this is what we want from a structured data analysis. I don't want to just write SQL, because before I write SQL, there are a lot of work to be done just to get the query writing, right? So we have to make the data structured and so many things. So Spark SQL is not, that's why the Spark SQL is not a great name for the library, because it says, okay, it's a SQL on top of Spark or something. But Spark SQL is saying, we want to solve structured data analysis problem end to end, right from discovering the schema till saving the structured data. We want to have a complete solution rather than saying we just write SQL. So that's why I wanted to show you the data source API, which means from now on, if you are working with Spark and if you are working with structured data, I encourage you to use the data source APIs rather than using a text file or any input format we seen before. And if you are already working with HBase or MongoDB, you may have seen table input format, MongoDB input format, and those kind of things. Slowly they are going to support data source APIs directly. You can say SQL context load from MongoDB, right? So that's going to be the idea. Now what we see is going to do is that let us open the sales.json. So what I have done is that I have same data sitting inside the JSON file. Now in the JSON file, there is no idea of headers, because every row has the key and value pairs. Are you able to follow what I'm trying to say? It's the same data, but what I want to do is that now it comes from a JSON source. Now let me see what is the line of code I have to write for JSON data source. I will just open the JSON. Okay, just say Alt1 so that we get the whole thing. Okay, does it look exactly same? Right. So what I say, I still say Spark Context, everything same. The only thing change is that I say org Apache Spark SQL.json, which means to the load I am saying now is that now it is a JSON data. Okay. Then I say I don't have header idea anymore. I say path is this one. Then again, how I am getting the schema? Exactly same. Which means irrespective of which is the structured data source, there is only one way of doing things, right? That's why I call it a universal API, right? CSV, JSON, whatever it is. I say SQL load, give the whatever the path it is, then they say, okay, this is the file you are getting. You do the work of schema discovery, and how I get the schema again? df.schema. No more we are saying RDD of JSON or RDD of those things. We are not having that. Whatever we load, we get the exactly same representation, and how we access the schema is exactly same thing, irrespective of which source it comes from. Are you able to follow what I am trying to say here? Okay, so let us run this example with the JSON. It's exactly same parameters. We'll just show you the parameters because some people say we watch videos and we don't know what to pass. And that is not there in the documentation. So we want to just show that what exactly how to pass to this. So here I think we just pass the JSON. Let us run. Okay, we have not passed. And I'm not sure how many of you are running it. Don't worry, everything is out there in the internet. You can run home also. Right, so yeah, JSON. Do we have a local? Okay. So let it run. Yeah. So if you just make it big a little bit. Right, so yeah, anyway, no use. You get the same exact same fields. Now, how it discovers schema for JSON to CSV is different, but you don't care. Ultimately, you get exactly same field names if you read from CSV or if you read from JSON. Are you able to follow? Yeah.
So in this case, can we detect the field type also?
Yeah, actually, field types also is detected.
How do we do
Yeah, so we'll show you that. Just go to the code. We'll change that code. So we remove the println. We say df.print schema. There is another API to print the whole schema. Let us run this. Right. Anyway, Scala takes a little bit time to compile. So how many of you are using Scala inside your companies? Oh, great. Only for Spark or any other use cases? Only for Spark. Okay. Is it right? Okay, Rani? If you can see here, this is the more broader schema. It says this root is because JSON is a nested structure, right? So we have a flash structure here we are using. We say amount paid double. It discovers a double because our all values are double values. And there is also an option called nullable equal to true because some sources also give this option that can that field null or not, particularly in the RDBMS. Sometimes it's helpful us because when we do processing in terms of Spark, if it is nullable equal to false, then I don't have to do null checks because data source makes sure that there are no nulls. But my normal nullable equal to true, if you see customer ID, it's a long. If you see item ID, it's a long, and transaction ID is long. It has discovered the field names for you. Not only that, it also discovered the data types for you. All are able to follow? If you do it in CSV, as of now, the implementation is everything is string. But I think over time they will improve and say we discovered exactly same as what we do in here. Yeah. Yeah.
Whether it will pass the entire file and then it will discover or
That's a question. So the question is, to discover the schema, does it go through the whole file or does it chase some portion of it? Now in the JSON, in the CSV, it is only first line. But in terms of JSON, there is something called sample ratio. You can specify. By default, the sample ratio is 1.0, which means it looks at the whole file to get the schema. But you can say, no, don't look at the whole file because I know most of the rows are having the exact same schema. I can say sample ratio is 0.1, which means it looks at the 10% of the data. That is settings is there in the JSON. We can say sample ratio is 0.1. Then it only looks at the 10% of the data. So that is configurable. By default, it's whole data.
Is it during that SQL context load?
Yes. When you say load, it's going to read the data and look for the schema. That's what I told. It's not like a text file which is lazy. This is not lazy. It has to look at the data in order to discover the schema. Are you able to follow till here? Now what I thought is that if I have exactly same schema in JSON and CSV, do I really need to say that in program? Can I send it as a parameter? Because what happens is in some of the use cases in the companies are, I get the same exact data but different formats. Right? I get from one source same schema but in CSV. I get from one place same schema JSON. Now what I have to do in normal programming, I have to have two programs which just says, okay, take the JSON and pass it and give it in a common format. Take the CSV and pass it and give it in some format. But I thought data source should be universal, right? So I wrote another example. Let us say we say mixed sources. What it does is it takes the path as a parameter. Now we are even taking source as a parameter. We say you tell me the source, whatever you used to specify, org, Apache, JSON or Databricks CSV. You tell me the source. I just plug it in here. I will give the path, and these options, if it is CSV, it will be used. If it is not CSV, it will be not used. Are you able to follow? This is what we ultimately want to write in our programs, where you say, I don't care what is the format of the file. I just want to know that is it exactly the same schema. Are you able to follow? That's where we want to get in. I don't care, is it a JSON or is it a CSV? You tell me the file format and the data source where I have to read. I just have to make sure that you have a contractual saying that it's exactly same schema. Because if the schema changes, then I cannot do the processing. But if the schema is same, I don't care about the actual format of the file. Are you able to follow what I'm trying to say? I'm trying to show you here is that as we are taking path as argument, we also going to take source also as a parameter, which means you tell me the source, whatever the source, it will do the actual loading, and once you are loaded, I get the schema. Are you able to follow? So which means this is more flexible. Not only I can specify the source inside of my program, it can be a parameter also, which means on the runtime I can say, oh, this is a JSON and this is a source from where you get the implementation, how to read that schema. Or it is a CSV, or you may write your own libraries inside your company or your organization saying that this is my custom source, but don't worry, you get the same schema, but I give you the data source also, that this is how you have to read. Makes sense? Yeah.
In one of your slides in the beginning, you said Spark SQL can work on top of JDBC also. Right? So, how do you load?
That's a good question. So, if you have a Spark SQL working on JDBC, then we use Hive Metastore. So, this is not exactly way of doing. So, what we do is that we run a SQL JDBC server and we write a normal JDBC, and the actual tables will be sitting in Hive Metastore. So here what we are doing is that we are doing schema discovery on the fly. But when you do a JDBC, the schema has to be stored somewhere. Are you able to follow what I am trying to say? There are two modes. One is on the fly Metastore, that's what we are doing here. The another thing is that permanent Metastore like Hive. So it can connect to Hive Metastore where already the schema is sitting. And when you say select star from this table, it goes to the Metastore to say what exactly is the schema. Are you able to follow what I am trying to say? So that is a different mode of operation.
So when you say it will fetch the data from Hive only, or any RDD and database like Oracle?
No. So here I mean that in the Metastore you have a schema. Now the schema can point to a HDFS file or it can point to something else. So there are two parts. One is actual data, one is schema. Now the schema has to come from some Metastore. The schema, let us say it comes from Hive. But actual data, it can come from RDBMS or HDFS or S3 or something.
Maybe I
I will answer this.
Yeah.
Actually, there are implementations that change. Previously, JDBC is more tied towards high context range, but now similar to the JDBC, what we have, right? So any other data source, we also have a JDBC data source, which can connect to any data source. Okay, and it can get schema and as operate. It can be any data source. There is no
Okay.
restriction.
Yeah. So that's a good question answer. So because there are two answers to this. One answer is that what you are looking for. Are you looking for getting the data from RDBMS and run a SQL on top of it? Or are you looking for a way to run a JDBC code against some data sitting in Hadoop or somewhere? So what is the kind of thing?
So in our case, basically, we have a data sitting in the RDBMS.
Okay.
It's a OLTP.
Okay.
Right. So that we want to move it to some OLAP data store.
Okay.
Right? In between, we want to use Spark SQL.
Okay, great. So then what happens is that in that sense, where here, just let us go to the JSON one example. Here you can say or Apache Spark SQL JDBC. Then in the option it takes a JDBC string itself. Then you can directly contact to RDBMS and load the data from there. So as you have a data source for CSV or JSON, there is a data source API for RDBMS also. And it can talk to any RDBMS. It talks through JDBC interface.
Okay. So that is coming. Okay. That is coming from Spark SQL.
Yeah, built into, yeah, it's a built-in. JDBC support is built into the Spark.
Okay. So we have to give both JDBC URL and then the query.
Uh,
The data.
Yes, you can give a JDBC URL and you can say query, correct. You can take, there are two options. You can tell the table name only, then it gets all the tables, or you can pass the query which you want to fetch the data.
Actually, the parameters next to you can say it map path equal to in the example there.
Yeah.
There you can give connection string, okay, table name, what
Correct,
interface,
correct.
you can give the details there.
Correct. Exactly. So in the options, you can say all those things.
Madhukar,
Yeah.
how can I view it as a data frame? I mean, like, what are the operation do data frame have? Is it similar to RDD or?
Good question. We'll have that in the future slides. We are not yet talked about DataFrame, but we will going to see.
Okay, and one more thing.
Yeah.
So is SQL context like a namespace or is it like a Spark context? Like Spark context communicates driver program and does some scheduling.
Correct. No,
Dash
yeah.
scheduling.
SQL context is just the namespacing. It's just the API layer. There is no infrastructure associated with it. Okay. Any other questions? I'm hoping all are able to understand what's going on here, right? Okay. So let us run this example. Okay. What is the example? Mixed sources. Now, just to show you what exactly the parameter we have to send, go to the edit configuration. Here, let us go to, okay, we have to pass three things. We have to say local. Yeah, we have to create an application. Okay, don't do that. Just right click and create. Right. We have to pass local. Second one. Yeah. We have to also pass the path, which path it is. So we are saying, let us say, source main resources CSV. Sales.csv. Sales. And then the third parameter here we are taking, which is the data source. We can say com.databricks spark.csv, which means now we are making this as a configuration. We are saying we will tell you the data source, we will tell you the path. You don't have to tell in the program because I don't care. Whichever the data source, I only care about the schema. So here you can pass a JSON or you can pass a CSV. You can pass any other data source. You can give as a parameters. Then it will load the data for you. All are able to follow. We started initially with the data source specified in the program, but that is not necessary always. You can make them as a parameters also. And if you see, we get the exact same schema. You can run this for a JSON also, then you get the exactly same schema.
Meta store can also become part of source as a parameter.
So yeah, it can become a parameter. All are able to follow till here? All are able to understand data source API? Now this is something new which is not there in Hadoop ecosystem. Right? They don't have this idea of universal way of loading structured data. Right? So that's what I wanted to focus on because this is what you have to maybe you have to use in future wherever you want to work with any of the structured data sources. Right. Let us go back to slides. Any questions here? Okay. Fine. Now, The next question is, once I load the data, what is the representation going to look like? What is the DF? Right? Is it an RDD or is it a something RDD of something or something? Right? No. We have a new abstraction in Spark called as DataFrames. Okay? There is a single representation or abstraction for representing structured data in Spark. Because when we were discussing about the problem with the structured data, the first problem we solved, we have auto discover schema using data source API. Now the next problem we have is that how we are going to represent the data once we load the schema, right? So we have DataFrame API. Now what is a data frame internally is, it is a data represented in terms of RDD with some schema. So RDD plus schema is equal to data frame. Now if you've been following the data frames, earlier it used to be called as schema RDD. By name itself is obvious, right? Schema and there is RDD. But that is not a great name, so that's they have moved it to something called data frames, right? And data frame idea do not come from Spark, it comes from languages like R and Python Panda, right? So there are other libraries who are already using this abstraction. Spark just using it in a big data world, right? All data source APIs return single abstraction, that is a data frame. So any data source you use, irrespective of data source, they return data frames. Are you able to follow? That's why I told you that's a single abstraction for any structured data, right? It is introduced in 1.3. 1.3 is the latest version now we have. I think 1.4 is going to come in next month or next to next month. This is the latest introduction. If you are using 1.2, I think you may be working with schema RDDs. 1.3 they have changed the APIs. Now you can say, oh, we have something new. How I can get back my RDD? Simple. On a data frame, there is a method called .rdd. It gives you back the RDD if you want. Right? If you don't want to work with a data frame, but if you still want to use the data source API, what you can say is that get me the data frame called RDD, then you get a RDD of something called row. You get back the same exact representation. And now not only they use data frame for abstraction layer, they also starting to support DataFrame DSL, which is found in R and Python. The idea here is that a lot of people, particularly data scientists, now in the big data world, now there are two people like separate roles. One we call data engineers, who are going to write Hadoop, MapReduce, Hive and Pig. And there are someone called data scientists who are normally going to work with the R and Python and modeling create. Now for people who are data scientists who are coming from R, DataFrame DSL is geared towards them. Right? If you are coming from that background, you can write in the way you used to work in R or Python. Now you can write the similar programs on top of Spark also. But if you say
R is supported in Spark, like R library.
Okay, so that's a good question. So what is the support for R? There is one project called Spark R, but it's going to be integrated into the core, I think from next version or next to next version. I think in 1.4 or 1.5, they're going to be
1.4.
Yeah, 1.4 itself. They're going to be R API, exactly same as Scala, Python, and other APIs. Right. Okay. Now let us go to next. Now, how we query, right? Once I have a data frame, how I query? Yeah.
Let's say you have a terabyte of data and you are trying to load using Spark SQL context.
Correct.
Right. So all of them are going to be stored in the memory. I mean memory. Or
No, this is an RDD. Internally, even if you use SQL context or data, anything else, internally it is stored as an RDD. And once you say an RDD, it's exactly what we were talking about, partitioning, input format, all those kind of ideas are same. It's not going to be loading everything into the memory. Only thing is that it's going to process the data for discovering the schema. In terms of if you say 1 terabyte of JSON, if you don't tune it, then it's going to run on 1 terabyte to discover the schema for you, but it will not load the data. It's exactly same as RDD representation we had earlier. So data frame is just another layer sitting on top of RDD. So, any other questions? Are you able to follow? Go on. What is the time? 12:40. 11:40. Okay, we are going great. Now, once I load the data, I get what I say, data frames. Now you say, I don't know data frame, right? I don't want to work with the data frame. So don't worry, data frames you don't need to use. You can get a data frame and write a SQL query on top of it. We're going to see that. So we have a built-in Spark SQL interpreter and optimizer, which is very similar to Hive. How many of you heard of Shark in Spark? So there used to be a project called Shark, which is a Hive on top of Spark, which means they used to use the same Hive interpreter, but rather than generating MapReduce, it used to generate Spark. But now it's gone, so they have their own implementation of interpreter and optimizer inside of Spark. It supports both Spark SQL and Hive dialects. You can use both. So there is a support for both temporary and Hive metastore. That's what we are talking about earlier. It has nice support for UDF, UDAF. If you have worked with Hive, I think you know. You can write user-defined functions, user-defined aggregator functions, partitioning, all those kind of things. All are supported by default. And we're going to see how to query. And this is the only example where we are actually going to see some SQL. And it's very easy, right? We'll see one example. Let us see, I have a loaded CSV file. How I'm going to query that, right? I think the first, these 3 lines are exactly same. We already seen what it does. They do schema discovery. Then what I can do is that I can take a data frame and say register temporary table called sales. Now here what we are trying to do is that we are saying we don't have a metastore, but whatever the schema you have discovered, give a name called as sales. All are able to follow what I am trying to say? In the Hive we say create table sales with these fields and data will be coming from here. What we do here is that we take the data, we discover the schema and we say, oh, we already have a schema, let me give a name to it. That's what we call, that's why if they say the API, register temporary table, because this is only for processing purpose. There is no real metastore sitting here. All are able to follow? Once you have the thing, then what you can do is that you can say SQL Context.SQL, then you can say select count star from sales. This is very similar, right? So once you have a data frame, you register as a table. Then once you have a table, then you can write any queries. There are a lot of ways to write queries actually in the API. I'm not going to cover all. One of the way I can say SQL Context.SQL, then this. Now the question is, what should be the return type of a SQL query? What is the normal SQL query returns in the JDBC and all? We get a result set. Right? We don't get a result set here. The reason is that even SQL queries in Spark are lazy by default. Unless you ask for collect, those queries are not going to run. And there's a reason behind that. The reason is that if you have sequence of queries and you say collect, they can do a lot of optimization. This is exactly same what pig does. Right? If you do a lot of transformations and ultimately you say dump or store, then it can do some optimizations. Here what you can do is that whenever you write a query, it is not going to run. What it does is it says, okay, whenever you ask for a result, I will run for you. So when I say collect, then only it's going to run. Are you able to follow? This is exactly same what we do it in the Spark, right? When you say Spark, we say, okay, you do all the transformation. When we say collect or save as text file or something, then actual data will be, or processing will be kicked off. Exactly similarly here, even if I say SQL, then I don't get the results immediately. It's a lazy by nature. This is a big difference compared to Hive or any other things. In Hive, if you say query, it immediately runs. Right? There's no option to say no, wait, no. Here, that's not a thing. That's why we cannot get a result set back. What we get back is a data frame again. Now, for a SQL query, can we discover a schema? We can. Because if I start with the schema, any SQL query I write can be auto-discover schema, right? I know what is the count star will return. A number. Right? So idea here is that data frame is a combination of data plus schema, and this schema can be discovered on the fly. You don't have to specify anywhere because some data sources will already have the schema. You start with that schema, and every SQL transformation will allow you to represent the schema or discover the schema by itself. Are you able to follow what I'm trying to say? That's why even if you load the data from source or if you write any SQL queries, what you get back is a data frame. That's why data frame is a single abstraction for any structured data. Maybe the structured data coming from the source or the structured data coming from some SQL transformations. Makes sense? And this is much more advanced than what we have in Impala or in Hive. We don't have this data structure sitting, right? So it's all about just we do query, get the results, and then you are your own. But here we say whatever you do, it's exactly same as Spark RDD, right? Whatever you do, you get back the RDD. Similarly here, whatever you do with the structured data, you get back DataFrame. And if you want to say what is the data from in one line, DataFrame is in the one line is a way to represent row and columns. That's it. So internally, that's what they do. And of course, how you get the results back? Take the data frame, say collect, to list. Then you get back the other data. All are able to follow what I'm trying to say here? Similar to what we had in RDD world, in the structured data world, we have a data frames. And internally, it's of course using RDD for storage. But what is the new thing in data frame compared to RDD is that schema part. Data frame has to have a schema always. But in RDD, you don't need to have a schema. Right? All are able to follow what I'm trying to say? Okay, let us run this example. And if you think about it, now, what if I want to do for JSON? Only the first 3 lines will change. Then everything else will be remains. And also, if you see here, I am writing SQL inside a program because it's a library. I am embedding the SQL rather than having a separate system which has to do the SQL. All are able to follow. That's the difference between framework versus library concept. Okay, so ultimately we get we have I think 14 columns, but that do not matter anyway. Okay, let's go to the slides.
Madhukara,
Yeah.
when you run the Spark SQL query,
Yeah.
and explicitly specify color, then only it will be operated. Otherwise, it will be lazy.
Correct.
But load will be always active.
Correct. So question was, if I don't call collect, is it going to run the query? No. If I say load, yeah, of course it's going to run some processing. If the data source needs to be auto discovered, you can write a data source where there is no schema discovery, then it's not going to run. So, but most of the data source have a discovery part. Okay, next. Now, I told you in Spark SQL there are 2 APIs to work with. You can write SQL because that's what most of the people are going to do anyway. That's why I shown you the first time. But there are some places people are saying, oh no, I come from an R background. I know the data frames. I don't want to write SQL. I know the DSL of the data frame. Can I work with it? So you have a DataFrame DSL. It's a DSL express for whatever you write SQL transformation, right? You can write in a different DSL here. Geared towards data scientists coming for R and Python. So if you know already, you can use it. Both SQL or DataFrame uses exact same interpreter and optimizer internally. If you write in terms of DataFrame DSL or if you write in terms of SQL query, internally they are exactly same. So which means all the performance or all the things what you can do with the SQL, you can do with the DSL. So it's just the option you have. If you are coming from a data warehousing world where you already know SQL, then you can use the SQL API of it. If you are coming from a data scientist background, then you can use the DataFrame DSL. It's just an option to say what is the best way of expressing the computation I want to do here. Okay? And SQL or DataFrame is up to you to decide. Personally, I use SQL because I come from a data engineer background. But of course, if you have a data scientist in your team, they may like to use a DataFrame API. I will show you one example just to give you a feel of how it looked like. And surprisingly, it looks like a MapReduce what we write in RDD. We'll show you. Let me go to the aggregate data frame. Alright. Now you got a data frame. We don't need to do register temp table because register temp table only for SQL API. Because SQL needs a table name. If you are doing data frame based aggregation, if you have never seen data frame, it may be new to you. You can say data frame aggregate, and it takes this map or a tuple which says which column and what aggregation you want to run. Rather than saying count star, I can say star and count. Okay, I'm just showing you the small peek into the DSL because I think most of you have never done data frame in any other language before. There are so many other APIs to work with, but in terms of what we done count star in the SQL, if you want to represent exactly same in terms of data frame API, this is how you write. Of course, in the data frame there is map, flat map, similar to what we have it in the RDD world. All are able to follow? So this is just 2 different APIs for the same core internal, depending upon what kind of people they are targeting into. Now see, Spark has 2 basic ideas. One thing is that they want to run all kind of data processing on top of Spark. That's why you have so many libraries. And they have another target is that they want to support all kind of programmers. Different languages, they support Python, Java, Scala, and R these days. And they want to also cater to all kind of programmers like data engineers, data scientists, and more. So Spark want to be a single framework for all kind of data, all kind of engineers, and all kind of languages. So that's their focus. That's why they are adding multiple APIs for the same code. All are able to follow? Yeah.
In the beginning you said that data source API deals with both load and store.
Yes.
So far we have seen load.
Good question. So we have a store option, one example, how to store as. Good question, yeah. Any other questions still here?
RDD basically in layman terms, RDD is for only storing data and DataFrame is for only storing schema.
Good question. So in the layman terms, RDD is a distributed data which do not have any schema. DataFrame is a RDD plus schema.
Okay.
This is a wrapper around schema plus RDD. And DataFrame you think like a data structure which holds RDD and a schema. That's all.
Okay.
Make sense? Any other questions still here?
And the previous example, actually we have registered a table.
Yes.
In the next, when we are using DataFrame, we didn't register.
We don't need. We only need a table for a SQL API. If you are using SQL, then you need a table. If you are not using SQL and if you are using DataFrame API, you don't need to register a table.
Because it will be holding the table schemas.
Yes, because anyway DataFrame has a schema.
Okay.
But since because there is no way to say select star from no table, right, in SQL. So you have to have a table name and somewhere the table name has to come. That's where we get the table, right? Okay, so we exactly get 14 because that's the number of rows. You do it in SQL, you do it in DataFrames, it's up to you. But you have to remember one thing is that DataFrame has two parts to it. One is it's a way to represent the data in the structured manner, and it has its own DSL if you want to work with it. But you can use one part that is a representation and use the SQL to do the aggregation, or you can use both the parts. That is up to you. All are able to follow what I'm trying to say here? Okay. What is the time? 11:50. Okay. Now you can say, oh, it looks like an RDD transformation, right? If I've not shown you map and flat map. DataFrame even has a map and flat map. There was a question that what is the difference between DataFrame transformations compared to RDD transformation? Are exactly same. I will give you some idea. The reason here I'm going to focus on this is if you have gone through the latest Spark API or Spark documentation, there is a lot of people saying you should use DataFrames more and more compared to RDDs. Right? Why? So let us talk a little bit about it. The first thing is that when you do transformation in RDD, the actual transformation is shipped on the cluster. What I mean by it? So when I say RDD.map, there is a function, right? That function gets serialized and distributed on the cluster, which means actual your code is going to run. But when you do DataFrame transformation, there is going to be an optimized version going to be running on the cluster, which means there is going to be multiple steps to take your processing function. They will do a lot of optimization. Then that optimization version is going to be running on the cluster, which means if you do RDD transformations, what you do is that whatever you write is whatever you get. But if you do DataFrame transformations, then there is going to be an optimizer sitting in between to do some optimizations. That is the one thing. The second thing is that in RDD, there is no schema needed. You can take any data, start with the transformations. In DataFrame, the schema is mandatory. If you don't have a schema, you cannot create a DataFrame. As simple as that. Which means DataFrame is created for structured data. So if you want to do anything else, RDD is the way to do it. Are you able to follow what I'm trying to say? Third, there is no parser or optimizer in between. Now, this is like a pig versus MapReduce. Right? If you write in the pig, there is an optimizer and generator sitting in between which runs a MapReduce code. But if you write a MapReduce, that is the lowest level you can write it. Now it has a benefits and like drawbacks, but that is exactly the same way. Of course, DataFrames internally using SQL parser and optimizer to do the actual code generation. Are you able to follow? Fourth thing, RDD is the lowest API you can access in the platform. That's the lowest level API. DataFrame is built on top of RDD and SQL. So it's a higher level abstraction. If you want to give an example, Pig is the higher level abstraction, MapReduce is the lowest level in Hadoop. Right? So that's kind of example. Now, RDD do not have this idea of smart data sources or even the data discovery and those kind of things, because it still uses input formats, right? If you are doing RDD things, you do not get all the smartness or the schema discovery, whatever you get from a source. So here what I'm trying to say is that you can take a data source, then you can do some RDD transformation on top of it. But thing is that once you say .RDD, all the optimization, all the smartness, whatever you have with the source is gone. Are you all able to follow? Of course, we'll see one example. It makes effective use of data sources in the data frame because they are built for that. And finally, this is very important. How many of you use Spark with Python? Yeah. Okay, so this is for those guys. In RDD transformation, every language has different performance characteristics. If you write an RDD transformation in Scala versus if you write a RDD transformation in Python, Python normally is around 10x slower than Scala. The reason is that the way we do serialization and the way we ship and run the code is going to take a lot of overhead in Python compared to Scala. But in DataFrames, all have exactly same performance. Which means if you are writing Python and you say you have option of writing RDD transformation versus DataFrame transformation, I say go with the DataFrames because you get exactly same performance across all the languages. The reason is that they never ship the actual code. They generate the code from the transformation you have done, which may be a Scala internal. All I want to follow what I'm trying to say, you represent the thing in Python, but ultimately it may not running a Python code exactly. They may be running other code which is generated from those transformations. Now, these things are not coming from me. I just show you some graphs which are shown in the last Spark Summit from the Databricks and saying how they are measuring the performance. Let me show you a graph. This is one thing. What they are doing is that they are aggregating around 10 million integer pairs and saying how fast we are. There is two comparisons here. One is RDD transformation versus DataFrame transformations and different languages. If you see in RDD Scala takes like 4 seconds. In Python, it takes around 9 seconds. Are you able to follow what I'm trying to say? Which means the Scala is 2x faster than Python. Exact same code, exact same data, but if you are writing in Scala, if you are writing in Python, the RDD source code, then there is going to be a slowdown in Python. Look at DataFrames. The first thing you have noticed here is that DataFrames are faster than RDDs. That is the first thing you represent here. Second thing is that both the languages have exactly same performance characteristics. Now you can say, wait a minute, if DataFrame is faster than RDD, why we use RDD? Right? But this fastness is coming from schema. Because once you know the schema, you can apply a lot of optimization, what we normally do in RDBM. Right from indexing into the compression, a lot of things you can do. That's why DataFrames are faster. But if you don't have a schema to start with, then you cannot use those kind of things. And of course, this is specific to the use case. Not always DataFrames are faster than RDDs, but most of the cases they are. And so there are two benefits to go with the DataFrame. The first benefit is they are faster than RDD in most of the cases. The second thing is that irrespective of which language you use, you get the same performance characteristics. So you don't have to give up your Python for better performance. If you are using Python, you can still use Python. You get exact same performance if you use Scala or Java. All are able to follow what I'm trying to say. This is why, particularly the Spark community now, more and more people are saying use DataFrames whenever it's possible. If it is not possible, then go to RDDs. Because earlier to DataFrames, we had only one way of doing things, that RDD. But now we have two options. We can go with the RDD, we can go with the DataFrames. Most of the cases, people say go with the DataFrames. You don't need to use DataFrame DSL because you can write SQL queries. Of course, there are a lot of problems in the big data which cannot be written as SQL queries. Then you can go with the DataFrame DSL. Now, if you are not able to do it in DSL of the DataFrame, then go with RDDs. All are able to follow what I'm trying to say here? Of course, if you don't have a schema, then there is no option, only RDD. Right. But now we have more options in the framework to choose, and more options also comes with more confusion. Right, which to choose, because earlier there was one RDD, okay, let's do RDDs. Now there are DataFrames, who knows, 1.5 what it comes. Right. So you have to be aware of where to use what. Okay, so let us, there is another graph I think. Now you can ask, how it is so fast? Right? What is the trick they are using internally? There is no trick because this is done over and over in all of the frameworks where there is schema. If you see in Pig, Hive, RDBMS, once you have a schema, suddenly you can have this pipeline. What is the pipeline they have? This is taken from a blog post from the Databricks. I encourage you to go through more detail exactly what it does. But from a very high level, if you write a SQL query or a data frame aggregation, I told you, right, it follows through the same pipeline. It do not matter. Do you write a DSL or do you write SQL? It's exactly same. Then you have this logical planning and physical planning. How many of you seen this in Pig or Hive? You can see the planning of the query or you can see the transformation, right? Exactly same pipeline they have. And what they do is that every new release, this optimizer will get better and better, right? So you do even have this idea of cost models, right? What is the right way of integrating with the data source? A lot of things they have, which means when you write data frame aggregation or SQL query, it goes through this complex optimization pipeline in order to get you the better performance. Now, if you do it in RDD, there is nothing. You go from RDD to the distributed system directly. So that's why most of the time the data frames are faster. Of course, with the caveat that these pipeline only can be applied if you have a schema. Because most of the steps here, particularly planning steps, they depend upon field types. Right? They do a lot of optimization on top of field types. If you don't have that information with you, then you cannot go with it. All are able to follow? This is not magic. It's not like you write a data frame and automatically everything is fast. The reason is fast because there is an internal optimizer sitting. And the nice thing is that this optimizer gets better and better over a time, which means your programs automatically become faster over a time. Right? That's the hope. Okay. Now, the final discussion we are going to talk today is, we already talked about data source API, we already talked about data frame API, we already talked about SQL and data frame DSL. The final thing I am going to talk about something called smart sources. Now this name is given by me. There is no really same thing called smart sources. Here the data sources are smart. Now what I mean by smart, right? The idea here is that in input format, there is no rich integration with the data sources. The input format treats a text file and RDBMs exactly same. But if you really think about it, they are not exactly same data sources, because RDBMS has, particularly in the deployments of RDBMS, you are deploying an RDBMS on a very rich machine, right, which has so much RAM and so much disk. It can do much more than just giving you the row, right? And also RDBMS has so much query optimization sitting inside, where it's given a column with the index or non-index, it can do a lot of optimization for you. So which means we don't want to treat the sources as a dumb sources, saying that give me the data, don't care how you want to do it. So what we are doing here is that Spark Data Source API is opening up a new way of integrating data sources, where they push a lot of information, what they are doing in the processing, to the data source and say, you do the right choice, rather than we doing the right choice. For example, I say, I want to do filtering, but I don't do filtering exactly same for all the data sources. What I say is that, I want to get the column of this, you do the filtering yourself. Maybe the HBase says, oh, I know, there is this way of doing filtering. RDBMS says, oh, there is a different way of doing filtering. Or some sources say, I don't know. Take the row, you do the filtering. All options are possible. But here, what we are trying to do here is that, if the data source is smart, the Spark will give the information what it requires, and it does the optimization. Right? So, smart data sources are the one which has support for server-side filtering. For example, if you use the HBase, HBase has this concept of server-side filtering, which means you ask for the filtering, it does in the server side, only pushes the output to here, rather than we doing the filtering in MapReduce. For example, what we are going to look at Parquet. Parquet is a smart source sitting on a disk. HBase is there, NoSQL, Cassandra, RDBMS, all are these smart sources. Now, what we do here is that, how we already seen there is an optimizer. Whenever optimizer determines it only needs few columns, how it determines is, there are a lot of ways to do it. One way is that, if I say select this field and this field, then I know only 2 columns. I don't need all the columns. What it does is, it passes this information to the data source, saying that, see, I am only trying to select these columns. These are the columns I want. Now it's up to you how you want to read and give it to me. It's not like you give me the data, I will filter the columns. Are you able to follow what is the difference? The first way is that I tell to data source, give me this row, and I know which columns I want, I get the filtration done. But here I am saying, I know which columns I want, but I don't do the filtering. I tell to the data source, you do the filtering, give me the data. The reason is that once I have that information in the data source, I can say, oh, I know the best way to do the filtering for you, rather than doing the filtering the way you do, right? So that's the kind of thing. Of course, data source can optimize for reading only columns, because most of the time analytics are done with the column-oriented data sources, and we can optimize for that. And there is more coming. For example, even there is I think in 1.4 or in the future releases, they want to share the logical planning, what they have created with the optimizer with the data source. The reason is that, for example, if you say the data source like HBase or Cassandra, they do have logical planning and physical planning, which is similar to what Spark SQL does. So what they do is that they say, see, from the SQL, this is the logical planning I have. You take it, you create your own logical planning, and then you give me the data. So which means it's no more just saying I need these columns. There is even future releases. They're saying we give you the logical planning, you interpret that logical planning, you get me the better and better results. So here what we are trying to do is that for a programmer, do not matter, right? I don't know anything about it. I get the data, I get the schema, I do the programming. But the people who are writing, let us say Cassandra, they are writing data source APIs, and they know more about Cassandra than me. So it is better them to do the decision to do how to do filtering or how to do the logical planning, rather than Spark people are saying, oh, we only know so much about Cassandra, let us do optimization for that. So what now Spark people are doing is that we do the processing, you take care of giving the data. But data source say we need more information. They say, okay, we give a better API where we give you more information. From that information, you do whatever the magic you want to do, but ultimately we want to get better and better performances. And that's where we are moving. We are moving the processing of how we want to load and discover the schema into multiple pieces, rather than processing engine making all those choices. Because most of the time they don't make smart choices because they don't know much about the data source. Are you able to follow what I'm trying to say? Now you can say, I don't have a HBase or I don't have RDBMS setting. I just using a normal text file. Can I get this benefit? Right? That's what I'm going to talk about now. Is that next? We have a new format called Parquet. It is Apache project. This is not directly integrated like a part of this Spark. What is the Parquet is? It is a column storage format for Hadoop. So it is a standard. It stores the data in terms of columns, and this is for Hadoop. Here it means that Hadoop means all the ecosystem projects which are running on Hadoop. So if you want to store the data in terms of column oriented way, and if you want to store the data in disk, then you can go with the Apache Parquet. Now, what are the things? If you use Parquet, you can read in the Spark, of course, you can read it in the MapReduce, you can read it in the Pig or Hive, whatever the things. Most of those projects these days, they support Parquet files. Now you can say, how it is different than a sequence file. How many of you have worked with a sequence file before? In Hadoop? No one? Great. Sequence file is also a binary format available in the Hadoop for storing the data, but it do not have the idea of column-oriented things. Right? It's just a key value pair sitting inside a disk, but this is more optimized. Supports compression out of the box. Internally, Parquet stores the data as a binary format, so you get that benefit. On top of binary, you can do compressions. You can do gzip compression, you can do snappy compression, all those kind of things. They are supported directly, which means you get a better and better. Optimized for column-oriented processing, which means this format is created for analytics. If you are reading one column, not reading any other columns, you get better and better performances. It's not like your normal TXT or CSV file. Supported out of the box, you don't need to put any library. You directly get out of the box in Spark. One of the smart forces which supports something called column pruning. Idea here is that when I read from a Parquet compared to a CSV, actually the data source can say I only need this column for my processing, and internally Parquet can only load that from the disk. So that's the kind of optimization we are talking here, which means if I say out of 10 columns, I only need one column, the Parquet internally only reads that column from the disk, nothing else even read from the disk. So that kind of optimizations you can get. Now, also from the compression, I can use some numbers. For example, I was working with a small file, let us say 1.3 MB CSV file. If you convert into Parquet without any kind of optimization, you get around for 14 KB. Okay? If you don't enable compression, you are getting around 140 KB. So which means what is the first thing you have to do is that take all your text data which is sitting in your HDFS, run through Parquet. How to create a Parquet? I'll see you one example. It's very easy. If you have a data source API, you can convert it to Parquet very easily. Once you have a Parquet file, you get two benefits. One, great for storage because suddenly you have a better storage in terms of binary and in terms of thing. The second thing is that it's optimized for data source API, which means when you are reading only one columns, you get this smart source benefit. And third, of course, it integrates with anything else. For example, if you have MapReduce, you can say Parquet input format. You get the same example. Right. So what is the idea here is that I am working on one of the consulting project where we use Parquet as exclusively file format. So once we have the source coming in, maybe through like a CSV or a JSON, everything we convert into Parquet files and we dump into HDFS. And it will be read from MapReduce, Hive, and it will be read from Spark or something. Great for storage and great for processing, right? So now someone was asking where is the store example. This is where we come, because you cannot create a Parquet directly from a text file without writing some code. So we'll show you the how to create a Parquet file, and also we'll show you how to read and how you get those benefits. Okay, so let us say CSV to Parquet. Now, and it's very simple. Now what Parquet needs is only needs two things. It needs the schema, it needs the data. Now with the data source API, we already have a schema and we already have a data, right? So what do? We say, okay, load the CSV file. What we get is a data frame, and in the data frame we have another option called save. It says save. It takes exactly same parameter. It says which source you want to save as. We say we want to save as a Parquet file. Then it says another parameter. This parameter is similar to your Hadoop parameter. In Hadoop, if you already have a file, you get an error, right? Because the folder cannot exist in MapReduce. Here the option here is that save mode error if exists, which means if you are giving a path which already exists, what you want to do. There are a few options. I can say append, I can say update, I can say overwrite, and I can say give an error. That's up to you. So what I'm saying, I want to save like a Parquet file. If there is exist, I want to get an error because I don't want to overwrite some file. Then it's exact same options. So load and save looks exactly same, with only this option is more. And how many lines of code you need to write to convert from one data source to another source? 4 lines. Okay, let us say I have a CSV file I want to write to MongoDB. What do you do? Same exact things. We say org MongoDB, whatever it is, and whatever the path. You can save a data frame to any data source APIs with one line. Reason is that all understand data frames, because they create a data frame as an input, they take the data source for the storage. And how exactly they put the schema, that's up to them. I don't know how Parquet saves the schema. I don't care. I say I have 4 fields, save those 4 fields for me. And this is the data. How you lay out or those kind of things is up to you. All are able to follow? So this example shows you how easy to convert from one data source to another data source without even saying a schema anywhere at all. Because it's all auto-discover and it's all auto-converted. The reason is possible because it's a universal API. So there is only one way to load and save, and there's only one representation called data frame. Once you have a data frame, you can write into any data source which supports data source API. Make sense what I'm trying to say? That's the strength here. Okay, so what is the time now? Am I running too late? 12:15. Okay, I think I should give it to the other people also. So I will not run this example. I'll just show you the another example and we'll stop. Right, let us go to the how to read. Okay, just how to read Parquet file. Exactly right, how we write the CSV or JSON. You say org Apache Spark SQL Parquet path, and everything done for you. So here idea is that I don't need to know Parquet format. How to store a schema or discover schema is up to the data source. I say let me give the data, I get the schema. Once I have the schema, see, I am saying aggregate on transaction ID here. I know there is a field called transaction ID, but I don't know how it's laid out in the format. I don't have to care. I just have to know the schema discovered for me, and once I know the schema, let me run the execution. Are you able to follow? I just don't run this because I'm running late today. Let me see what I have in the slides anyway. I think I'm done here. Okay, so what we have seen today is that what I wanted to do it in this session is Spark SQL is more than writing SQL. right? It's just not just about SQL. It brings a complete solution for how to do structured data analysis. What I mean structured data analysis, loading the structured data, representing the structured data so that it can be sent between two different libraries, then running some queries using SQL or DataFrame API, and having the support for smart sources where I can make a lot of optimizations. So it's an end-to-end solution, and there's a complete set of APIs you can use which are not there in the earlier versions, or which is not even there in the other frameworks out there. Make sense? All are able to follow? And of course, these are the sources. Actually, there is not book. I think there's only one book on Spark till now. There's no book for Spark SQL because this is like 4 months old. So what you get is that you get blocks. There are 2 blocks from Databricks. There is I've given link for Parquet if you want to read, and also I have started a new series in my blog about data source APIs. If you want to read, you can go and have a look. And of course, we have Meetup and Code, right? Okay, so I think that's all from my session. And if you have any questions, I can answer, or we will take the questions later. Maybe we'll just hand it over to the QA guys. Okay, thank you guys.